Hi students, this section is 3.2, solving equations using multiplication and division. So when we are solving equations using multiplication and division, remember when solving equations you want to isolate the variable, meaning you want to get the variable all by itself on one side of the equal sign. And we're going to be working with remember, inverse operations. And we talked about this in class where if you're multiplying, the inverse operation would be division. If it's division, it's going to be multiplication. So here we're going to isolate, for example 1, we're going to solve the following equations. We're going to isolate for a, x. We have 8x equals 16. Well, what's the inverse operation of multiplication, division? So we're going to divide both sides by 8. On the left side, 8 over 8 becomes 1. So we're left with x equals 16 divided by 8 is going to give me 2. And that will be my answer. Please make sure in the notes that you're writing down and showing your thinking like I did by dividing 8 to both sides and circling your answer. If we do the check step that we talked about in class, if we check, we would plug in 2 for x to make sure equals 16. So 8 times 2, does that give me 16? It sure does. So the equation is balanced. 16 equals 16, and we check that off. The next one, we have for b, negative 7 divided by b equals negative 4. So we are solving for b. So we're going to divide both sides by negative 7. So for b, we have a fraction, negative 4 over negative 7. We cannot simplify that. The reason for that is because 7 is a prime number. So, but we do have two negatives. Negative over negative becomes positive. So b is going to be 4/7. That'll be my answer. If we check this step, we're going to plug in 4/7 in for b. So we have negative 7 times 4 over 7. Now, when we're multiplying with fractions, you can multiply across. Negative 7 times 4 gives me a negative 28 over 7, which gives me negative 4. So negative 4 equals negative 4, and that checks itself out. For c, we're solving for x, isolating the variable, getting it by itself. We're going to take the inverse operation, dividing negative 3 to both sides. So x is going to equal 5 over negative 3. That will be my answer. And if I check my work, we can plug 5 over negative 3 back into the original. So negative 3 times my x, which is 5 over negative 3. Whoops. Here we can cross cancel the negative 3's if you wanted to, or you can just multiply across. And my final answer here is going to give me 5, and 5 over 5 equals 5. That checks itself out. Example 2 here, we need to solve these equations. Here we're working with division. So I'm going to rewrite a out here because we have a in front. So we have y over 4 equals 32. We want to solve for y, meaning getting it all by itself, isolating y. So what do we do here? We can multiply by the reciprocal to both sides. This could be like 1y over 4. So if we multiply the left side by 4 over 1, we multiply the right side by 4 over 1. On the left side, the 4's are going to cancel, leaving us left with y equals, well, 32 times 4 over 1, that's just thinking it as 32 times 4, which gives me an answer of 128. So when we solve for y, or when we do our check step, I should say, we're going to plug in 128 for y, so 128 divided by 4, yes, that gives me 32. So 32 equals 32, and it checks itself out. Solving for b, we have r over negative 5 equals 20. We're solving for r, meaning we need to isolate that variable, getting it by itself. So we're going to multiply the left side by negative 5 over 1, multiply the right side by negative 5 over 1. On the left side, the 5's will cancel, leaving me left with r equals negative 5 over 1. You can think of that as negative 5, so 20 times negative 5. And that's going to give me r equals negative 100. We can check that by plugging negative 100 in for r. Negative 100 divided by negative 5 does give me a positive 20, so 20 equals 20, and that checks itself out. Last one here, we are working with some more fractions rather than whole numbers, but don't let that confuse you by any means. So we have here 1 over 7x equals 5 over 7. And for this, we're solving for x, isolating the variable x. So we're going to multiply the left side by 7 over 1, multiply the right side by 7 over 1. So on the left side, we get x equals. Now, can we cross-cancel anything out here? We can, the 7. So my answer is just going to be 5 over 1, which becomes 5. I can plug 5 back into for x to see if we get 5/7. So 1/7 times 5 over 1. That gives me 5/7, which checks itself out. And that is it for the section.